Hello guys, this is Koney, currently working as a technical team at Automotive. Today I'll be talking about securing enterprise AI, and some of the different concepts including then how to secure our enterprise AI, which includes the governance, risk, and economics of LLM adoption. Let's take a look at the enterprise AI reality check. So what's the promise and what's the challenge? So large language models are currently transforming how enterprises are trying to operate. And it also includes like promising enhanced productivity, intelligence automation, and competitive advantages. Organizations across industries are racing to integrate AI capabilities into their core systems. And what are some of the challenges? Most LLMs are failing to reach production because there's like a significant gap between proof of concept and the production deployment, which actually remains wide. So some of the different things include that are like infrastructure complexities, compliance, governance, and security misalignment, creating like a formidable barrier for the ops teams. Let's take a look at why most LLM initiatives are failing. The first one is like infrastructure gaps. So currently there's like a lack of scalable and secure infrastructure designed specifically for AI workloads, whereas the old traditional systems are struggling with the compute and also failing to meet these storage requirements. The second one is like a governance vacuum. So there's like absence of clear policies of AI model selection and how the data should be handled and what are the decision making accountabilities, and the compliance framework lags behind the AI capabilities. These are not well-defined compliance requirements that are defined in the AI space. And the third one is like security misalignments. The security teams are basically unprepared for AI-specific threats, which includes prompt injection, model poisoning, data exfiltration through the model outputs. And the last one is like cost uncertainty, which includes like unpredictable expenses and unclear return on investment, makes it difficult to justify continued investment and scale beyond the initial pilots. Because with the AI systems, there's a lot of uncertainty in the token usage, and which drives towards like the unpredictable expenses and also unclear return on investment. Let's take a look at the three pillar frameworks for secure AI deployment. The first one is like strategic infrastructure, which is a pretty one of the major pillar for a secure LLM deployment. This particular choosing the right deployment model is pretty key. There are like three different deployment models, which is like infrastructure as code, software as a service, and the platform as a service. Each one offers different capabilities and control compliance requirements and also speed to market. The second one is like economical analysis, a rigorous time cost of ownership models that accounts for compute costs, licensing, operation overhead, and performance optimizations across AI lifecycle. And the last one is like operational safeguards, including like good practices and gateway architecture for enforcing like security policies, monitoring behaviors, and preventing costly failures in production. So let's look at the deployment models, starting with infrastructure as a service. So with the infrastructure as a service, the company has like full control over the model selection, fine tuning, optimizations, infrastructure configuration, which includes like provisioning the infrastructure, training the model. This is ideal for like highly regulated environments, which has like a really specific compliance requirements. Some of the trade-offs of this approach is high operation burdens, long time to market, because the company is responsible for maintaining the infrastructure, of fine-tuning the models, the operation life cycle. And this also requires like deep machine learning expertise and significant ops investment. The second one is like platform as a service. This is a balance between owning like the entire infrastructure, because you are using like a managed infrastructure approach with flexibility of the customization. So you are relying on a specific vendor for the infrastructure piece, but we still own the majority of the model development, fine tuning, and optimization piece. And some of the trade offs include like vendor lock in, unlimited infrastructure customizations, because we are relying on a vendor and those vendors might not support our requirements of the infrastructure. But this approach dramatically reduces the overall operational complexity. And the third one is like software as a service, which presents like pre-built solutions with minimal setup, which is essentially a best example is like Amazon Bedrock, perfect one for standard use cases and rapid experimentation with the minimal technical overhead. So we just use the AI software as a service. And some of the trade-offs includes like least control over model behavior, because since we are relying on the service, we don't have much control over like how the model should be behaving. And it also has the potential compliance concern because we are relying on a third-party service, large language models, and which includes like limited customizations for domain-specific needs, because there's like very little customization that we can do if you are choosing like software as a service approach. Let's take a look at 5 years total cost of ownership analysis. The first one is like infrastructure code. As I mentioned, compute resource, storage, networking, and scaling requirements. If we are using infrastructure as a service, this is one of the major total cost of ownership analysis that we have to perform, because we own the compute, we own the storage, and we need to tweak the network configurations and the scaling requirements. The second one is like licensing and model, which is common for all the three approaches: API modeling, model licensing, and hosting fees. The third one is like operational overhead. Any system, any software system needs to do a rigorous analysis on the operational overhead, which includes like monitoring, maintenance, security, and compliance. The third one is talent and training, specialized AI, machine learning engineering, and also needs continuous improvement and ongoing education for the entire teams. And the last one is like optimization efforts, which is a key, because continuous improvement, fine tuning, and efficiency gain, because the overall AI system should be performed, it should be optimized, and should be continuously fine-tuned for efficiency gains. Let's take a look at some of the performance metrics that drives the return on investment. The first one is like first token latency, so which is nothing but the time until the model begins responding. This is pretty critical for user experience, especially in interactive web application like a chatbot, because low latency always drives like higher adoption and also good customer satisfaction. And the second one is tokens per second. Throughput capacity determines how many concurrent users you can serve. So the higher the throughput, the reduced infrastructure needs and improves cost efficiency. So we need to provision like infrastructure that satisfies like higher throughput needs, so that gives us a good return on investment, so that we are not spending a lot on the infrastructure, but still provisioning a lot of user requests. And the last one is like utilization rate, percentage of provision capacity actively service requests. So optimizing utilization is the fastest path of improving the return on investment on LLM infrastructure investment. So let's take a look at the LLM ops operational excellency for AI. So the first one is obviously the development, which includes prompt engineering, model selection, and fine tuning. And when part of the prompt tuning, we need to define like a well-crafted prompt, using like different prompt engineering technologies to efficiently pass the contextual data to the LLM. And the second one is model selection. Using the right model for the right use cases is pretty essential, because if the use case is text-based communication, we use the right model. If the use case is about generating like videos or text, and we need to select the right model to solve the use cases. And the third one in the development phase is like fine-tuning, or overall fine-tuning the system for better performance, better output is pretty essential. The second one is testing. As the adversarial testing, bias testing, and performance validation. Since LLMs are non-deterministic, testing is one of the key part of for the operational excellence for the AI, which includes like bias detection early in the field a bit better, and we need to do really good performance validation of the overall system. The third one is like deployment. We need to do like a controlled rollout, include like A/B testing capabilities and camera releases, because let's say we are adding like a new feature, by doing like a controlled rollout, we get like feedback immediately. If there's like, something goes wrong, it doesn't impact the entire user group. And the next one is like monitoring, having like real-time observability around the AI systems is pretty essential, and also having a good cost tracking mechanism and also the quality metrics, because we can use this cost tracking and quality metrics data and do like an optimization for the system and identify if the cost is getting overrun. We can be able to quickly identify the places where using like this cost tracking system, and if we have to improve the performance during the performance optimization, getting this quality metrics in this monitoring phase is pretty essential for overall optimization, performance tuning, and cost reduction. This is of our system. The next one is like AI API gateway or security control panel. The first one is like authentication and authorization. It's just the key security metric that we need to be implemented at the AI API gateway, which includes like verifying the identity and enforcing like role-based control access. The second one is like rate limiting and quotas. Implementing like a token-based throttling prevents cost overrun and the abuse of the AI system. Since the AI systems mainly use like tokens for input and output, should definitely implement like some sort of a rate limiting or API gateway level, so that as I mentioned, it doesn't overrun our cost. The next one is input sanitization, which includes like detecting and blocking like prompt injection data at the API gateway level. And the next one is output filtering, which includes like scanning the responsive data and redacting the sensitive data before returning to this customer. And the last one is like semantic caching, one of the important aspect of this AI API gateway, so that we don't, which reduces the cost by caching like similar queries. So we rely on this cache to get answers for similar queries. And if we're not able to find in the query, then we rely on the LLM system which improves the overall optimization of the system. Now let's take a look at the critical security risk in LLM operation, which prompt injection attack, data exfiltration, hallucination risk, and cost overrun. Let's start with like prompt injection attacks. Because every system there could be like malicious users that are trying to craft input that manipulates the overall model behavior, and also bypassing like the security controls, and also extracting like the training data of our model. So implementing like a gateway level filtering and input validations are essential to mitigate this prompt injection attack. The second one is like data expectations. So some models may inadvertently expose sensitive information from the training data or on the context window. So output filtering and access control limited exposure. So we can implement both of these using our AI API gateway that we previously discussed. And the third one is like hallucination risk. So model generates incorrect information, create liability in the high stakes domain. So because AI could definitely make some mistakes. So considering like scoring and human in the loop validation will mitigate the risk where the stakes are high. The last one is like cost overrun. Cost can rapidly escalate costs because we can quickly get into this loop of hallucinating and thinking continuously in a loop. And there could be like some malicious users who are like constantly hitting our system. So we need to implement some sort of like a token-based rate limiting and budgeting alerts, which prevents like financial surprises. So that's the caution be a surprise for the organization. We should have good visibility into the cost usage and also good control over. Let's take a look at the domain-specific models for regulatory industries. So let's say, for example, like financial services and healthcare, they are like highly regulated and compliance regulated industries. So we need to have domain-specific models that specifically addresses the use cases in these regulatory industries, especially Bloomberg, GPT, and LLM. So these are like financial services and the healthcare industries. So these models are like specifically trained on this financial data and healthcare models, so that these are all the regulated industries. So using domain-specific models for regulatory industry use cases is one of the key essential when you're building like an AI system. Now let's take a look at the best practices for production LLM deployment. The first one is like implementing adversarial testing. As we already discussed, regularly testing models with malicious input and also the edge cases to identify vulnerabilities before attackers do. So consider all possible edge cases in the testing scenario is one of the important production ready system. And the second one is like monitoring continuously. We need to definitely track the performance metrics, the cost and security events in the real time with automated alerting, so that we need to have these strict alert conditions around the performance metrics, costs, and security events, so that we should be able to identify these issues sooner rather than later. The next one is deploying the semantic caching, as we discussed earlier. Build like a cached responses for similar queries, which has a performance improvement, reducing the cost and overall without sacrificing the quality. The next one is like version controlling everything, treating prompt configuration policies as a code with proper version controlling, so that we can roll back these capabilities quickly instead of doing like a hotfix. The next one is like enforcing tokens based rate limiting, as we discussed earlier at the AI API gateway level. We need to implement like a token based or a quota based for cost controlling and preventing any abuser users from hitting our system. So by implementing token limits per user per term unit with intelligent content management system. Next one is like implement fallback strategies, which is design graceful degradation when models are unavailable or produce low quality outputs. So let's say we rely on a model which generates like a really good output based on the user scenario. If, for example, that specific model is unavailable, so we need to fall back on using a low confidence output model, so that we generate an output to the customer instead of failing the entire user request. The next one is establishing human in the loop workflow, which is very critical decision, requires a human oversight, particularly in regulated industries and high stake scenarios. Having a human in the loop will be very essential and critical. Document decision trails, maintaining audit logs per model decision for compliance, debugging, and continuous improvements. We can maintain these decision trials and capture all the model decision for compliance, all the debug information, which we can use that information for continuous improvement for the overall LLM system that we are trying to build. The future multimodal and agentic AI. So the next evolution of enterprise AI moves beyond just text-only models, but to a multimodal system that processes images, audio, video, and text simulations. Agentic AI systems can autonomously plan, execute tasks, and interact with the expert tools. So currently, we are in the text. These are like the different stages of this AI. The first one is like text only LLMs. The current generation is efficiently using the LLMs for text generation. The next feature is like multimodals, which has the capabilities of processing like multimedia data. And the last one is like building this agentic system. So building this autonomous agentic system, which has the planning, execution, and adaptable capabilities built into it, the overall goal. The DevOps systems must be prepared for these advances by building flexible, secure infrastructure that can accommodate rapid AI evaluation, but while maintaining governance and really good compliance standards. From tools to the ecosystem, the integrated operative. Successful enterprises are moving beyond just treating LLM as an isolated tool and instead integrating these LLM tools and these governance ecosystems within their DevOps pipelines. This means embedding AI directly into the development workflow, security scanning, instant response, and operation modeling with consistent governance and operation across all the touch points. So, including AI in our day-to-day entire project development lifecycle is pretty essential. Starting from the development phase, building like a really good development workflow, using AI for our security scanning, instant response, and also like operation monitoring, but including really good consistent governance and observability across all these touch points. And some of the key integration points are like CI/CD pipeline for automation code review. We can definitely leverage AI for automated code review, which can be included as part of the pipeline and also as part of the security scans. And instant response system for intelligent triage and remediation. We can definitely train a specific AI model with some proprietary incident and the response data so that we can build this instant response system that could intelligently triage and remediate any incidents that we are occurring. The next one is monitoring platforms and anomaly detection and root cause analysis. We can definitely leverage AI for root cause analysis and root cause detection, which we can definitely leverage AI for faster identifying the anomalies and also identifying the root causes. And documentation system for automated knowledge base generation. We can definitely use AI for building like a really good knowledge base and train a specific model based off of the proprietary knowledge base information. So this is like from the tools to the ecosystem and integrating AI in the entire project development lifecycle from the development phase to the security scanning, instant response, and operation monitoring, and also anomaly detection, root cause analysis, and also building like a really good knowledge base system and integrating automated code review, security scanning into our CI/CD pipelines. Thank you so much.